This session is on Newton-Raphson method. It's part 2. Please look at part 1 for better understanding. We will look at how to find the roots of an algebraic equation by Newton-Raphson method, how to derive the formula, and we'll be solving few problems on it. Please like, share and subscribe this particular channel. Come to Newton-Raphson method. It is also known as method of tangents. Okay, I will be explaining you how this particular Newton's Raphson method would be solving the problems and finding the roots of an equation. Okay, if you consider a graph here, this one is the x-axis, this is an y-axis, right? And there is a curve here. It is a function, so it is f of x. It is an equation. Now it is meeting at a point here. If you consider this one as an alpha, okay, alpha is nothing but root of f of x. If you substitute the value of f of alpha, it will be equal to 0. Now we have to find the value of alpha. Now Newton-Raphson method would be using a tricky type of a method to find the root of a function or an equation. Okay, if you consider a point here somewhere, okay, in the graph, if you consider this one as an x0, it is in a straight line, right? And it is nothing but in height, which is y, right? It will be meeting at this particular point somewhere at the y, right? Which is equal to nothing but f of x0 only, right? Now if you consider a slope of it, then it is nothing but f dash of x0 only, right? Then we'll be getting some point here as x1, which is very much near to alpha, right? Now we have to find the value of x1. So if you consider the difference between x1 and x0 as a delta of x, right? So we can consider x1 is equal to nothing but x0 minus delta of x. What is delta of x? It is equal to nothing but, it is in a triangular form, so which is equal to nothing but height by slope, right? So which is equal to, height is given as y, which is f of x0, so f of x0 only, by slope is f dash of x0, right? So delta of x, we got it, so we can write x1 is equal to nothing but x0 minus f of x0 by f dash of x0. Then we're getting an x1 value, here value, right? Again you have to get the alpha value, again we'll be finding the height of it, then again we'll be finding the slope of it, which is almost near to it, right? Then we'll be getting an alpha value. If you consider alpha is equal to nothing but x2, okay, then x2 is equal to nothing but x1 minus f of x1 by f dash of x1, which is equal to alpha, right? When you substitute the value of f of alpha, then we get a value of 0 or approximately equal to 0, right? So this particular alpha value or x2 value is nothing but root of an equation f of x. This method has been used to find the roots of an equation. This is nothing but Newton-Raphson method. Now the formula is noted down here. Okay, if you consider f of x be a continuous function, okay, by using a Newton's-Raphson method, okay, we can find the root of an equation, right? The formula that we use is nothing but, it's very important, x of n plus 1 is equal to x of n minus f of x of n by f dash of x of n, right? Then the equation, if you consider n is equal to 0, then we get x of 1 is equal to x0 minus f of x0 by f dash of x0, right? Where x0 is nothing but starting value, initial value, or initial approximation value, okay? This is just an important formula you have to remember. Now the general thing that we have to consider is nothing but if the difference between x of n plus 1 and x of n is 0 or negligible, then we can stop the process, and the roots are nothing but x of n plus 1 or x of n. Okay, now we'll be solving a few problems on Newton-Raphson method. Come to the first question. Okay, the question is the equation x cubed minus x squared plus 4x minus 4 is equal to 0 is to be solved using the Newton-Raphson method. If x is equal to is taken as an initial approximation of the solution, the next approximation using this method will be. Okay, it is a gate question 2007. First, we understand the question. They are given an equation, right? There's an equation. So they are given f of x is equal to nothing but x cubed minus x squared plus 4x minus 4. Right? Again, they are saying it is to be used in a Newton-Raphson method. And initial value is given as x is equal to 2. So they are given that x naught is equal to 2. Now they are asking the next approximation value would be, okay, the general formula that we know is nothing but x of 1 is equal to x naught minus f of x naught by f dash of x naught, right? First we're defining those particular values, f of x naught and f dash of x naught. Now just up to the values, f of x naught, yeah, x naught is nothing but 2, right, which is equal to 2 cube is nothing but 8 minus 4 plus 8 minus 4, right? All those things we get cancelled, which is equal to nothing but 8, right? Then f dash of x naught, which is equal to nothing but 3x square minus 2x plus 4. Just substitute the value of 2 here. Then you get 2 to the 4, 4 into 3. It becomes 12 minus 2 to the 4 plus 4, which is equal to nothing but 12, right? So we get as 2 minus, here the value of f of x naught is 8 by 12, which is equal to nothing but, here it goes by 2, it goes by 3, it becomes 6 minus 2 by 3, which is equal to 4 by 3. So the next approximation value would be 4 by 3. Answer is option B. Now coming to Newton's-Raphson method to find the pth root of a number. Okay, assume that you have a number like 1, 2, 3, 4 and 5. It is a number. Okay, if you want to find the square root of a number or 1/3 of a number or 1/4 of a number, then we'll be using this particular formula to find the root of a number. You'd be having a number like n power 1 by p. Initially you would be assuming a number, let the root of it be x naught, and you'll be finding the x1 value. We'll be checking if it is fine or not. If not, we'll be finding out x2 value and so on. Okay, now the formula is nothing but x of n plus 1 is equal to p minus 1 into x of n power p plus n by p into x of n power p minus 1. Okay, now if you want to find the square root of a number like n square root, which is equal to n power 1 by 2, right? Now here p is nothing but 2. If you assume that n is equal to 4, we know that root of 4 is equal to 2, right? We'd be checking with this particular formula. Now here n is 4, p is 2. We'd be assuming a number x naught is equal to 2. Now x1, okay, now x1 is equal to nothing but, here x naught is 2 square, it becomes 4 plus n is nothing but it is 4 only by 2 into x naught or x of n is equal to nothing but 2, which is equal to nothing but 8 by 4, which is equal to 2. So the square root of 4 is nothing but 2, right? That's the method we will be using. If you want to find the square root of an 2, we know that it is almost equal to 1.414, right? Now in this particular case, we'll assume that x naught is equal to 1, say. Then we'll find your x1 value, which is equal to nothing but x naught square is nothing but 1 plus n is nothing but 2 here by 2 into 1, which is equal to nothing but 3 by 2, which is equal to 1.5, right? Now it is not nearby, so now again we're defining the x2 value, which is equal to nothing but 1.5 whole square plus 2 by 2 into 1.5, and so on we'll be doing to get the exact value of an root 2. Now find the inverse of a number. Okay, if you have something number as 7, 4, 3.23, okay, if you want to find the inverse of this particular number, then we can use a Newton-Raphson formula. It's nothing but x of n plus 1 is equal to 2 into x of n minus n into x of n square. That's nothing but n inverse when you find it out. For example, if you consider phi inverse, okay, here we know the value as 0.2, right? Now we'll be using this particular formula to find the phi inverse. If you consider initial value as 0.2 only, x naught, and n is equal to 5. Now use the formula x of 1 is equal to 2 into x of n, means x naught, initial value, it is 0.2 minus 5 into 0.2 square, which is equal to nothing but 0.4 minus 0.2, which is equal to 0.2, which is equal to x naught. So x1 is equal to x naught. So inverse of a number is 0.2 only, right? Now to find the roots of a number, you will be finding the value of x0, x1, x2, so on till n, okay, till we get the values of a number, root of a number or inverse of a number. If you consider pth root of a number, first assume a number and find the value of x0, then find the value of an x1. If the difference between these two is approximately equal to 0, then the value of that particular number, a root or inverse of a number, would be x0 or x1. Else you would be finding x2 also, and difference between these two is approximately equal to 0, then the root of that particular number is nothing but x1 or x2. This particular Newton-Raphson method is used to find the pth root of a number. Now coming to the question. The question is, identify Newton-Raphson iteration scheme for finding the square root of a 2. Okay, it is a GATE question 2007. Okay, they are asking to find the square root of 2. What is the formula used? The general formula that we know for Newton-Raphson pth root formula is nothing but x of n plus 1 is equal to p minus 1 x of n power p plus n by n into x of n power p minus 1, right? Where would you finding the nth root, right? Power 1 by p, right? Here it is given as you have to find for 2 power 1 by 2, then p is equal to 2, n is equal to nothing but 2. So just substitute the values, then you get x of n plus 1 is equal to 2 minus 1, it becomes 1, so x of n square plus 2 by 2 into x of n power 1, right? So which is equal to nothing but 1 by 2 into x of n plus 2 by x of n. So square root of 2 is nothing but option A. Come to the next question. For n is equal to 0, 1, 2, so on, the steps of a Newton-Raphson method for solving in a non-linear equation is given as x of n plus 1 is equal to 2 by 3 x of n plus 5 by 3 x of n power minus 2. Starting from a suitable initial cases as n tends to infinity, related to x of n tends to. Okay, as I get to the next question. First, to understand the question properly. They're saying that by using a Newton-Raphson method, they solve a non-linear equation. Let the non-linear equation be f of x. On solving that one, they got this particular equation. Now they're asking the value of x of n would be, right? But the general formula that we know for the Newton-Raphson method is nothing but x of n plus 1 is equal to x of n minus f of x of n by f dash of x of n. This is the general formula that we know. But we have to find the x of n value. Now what we do is nothing but first we're defining the value of f of x of n. Okay. The general thing that we know is nothing but x of n plus 1 minus x of n is equal to nothing but minus f of x of n by f dash of x of n, right? So we'll be solving this particular value to get this particular form. Now they are given the values, right? X of n plus 1 is equal to nothing but 2 by 3 x of n plus 5 by 3 x of n power minus 2. So we can write this one is equal to nothing but 1 minus 1 by 3 whole x of n plus 5 by 3 x of n power minus 2, right? Now we can solve this particular value and we'll be getting x of n plus 1 minus x of n is equal to nothing but minus 1 by 3 x of n plus 5 by 3 x of n square, right? Which is equal to nothing but minus f of x n by f dash of x of n. So which is equal to nothing but minus f of x by f dash of x of n, right? Is f. Now we'll be solving the values. Then we get f of x of n by f dash of x of n is equal to nothing but 1 by 3 x of n minus 5 by 3 x of n square, right? As a minus would be coming into the picture. Then which is equal to nothing but we get x of n cube minus 5 by 3 into x of n square, right? If f of x of n is equal to x of n cube minus 5, then f dash of x of n will be 3 into x square of 9, right? So we can write this one as f of x of n is equal to x of n cube minus 5. Then we can find the value of x of n when you equate it to 0, right? So we get x of n is equal to cube root of 5, which is equal to nothing but 1.7099. So the answer for the question is option A.